All right, today we have Semih Salihoglu, Associate Professor at the University of Waterloo in Canada. But most importantly for this episode, he is one of the creators of Kùzu, which I guess the quickest way to describe it is DuckDB for graphs. But the more official description on its GitHub repo is an embeddable property graph database management system built for query speed and scalability. And so, Semih, welcome to the Data Exchange podcast.
Thank you very much. Thanks for having me.
All right, so let's start with the basics. For listeners who are not graph experts, first of all, what is a property graph?
A property graph is a data model that is based after Neo4j's data model. That's a specific system and a specific implementation and the commercial leader in this market, where it is actually quite similar to relational model, except you get a bit more object-oriented modeling, where you specify a set of records as nodes and the set of records as relationships between the nodes. So it's closer and a little higher level than the relational model, closer to the entity relationship model.
Yeah. So is a property graph, Semih, for people who are not experts in graphs, is that a very specific type of graph structure?
Yeah, that is a form of graph data model. There has been many since 1960s, since the field was born, as the database field was born. There's many graph-based models. The very first one actually predates the relational model. It was called the network model or codicil model, actually. The very first database management system in history was this system called IDS, kind of architected by Charlie Bachman. And Charlie Bachman is a Turing Award laureate and kind of thought of as the creator of databases. And he had a model where you'd have certain records linking to explicitly some other records, and it was called the network model. So that's the first graph-based model. And throughout history, there's been object-oriented modeling. There has been XML-based databases, which are all forms of graph-based modeling. There's been RDF, and kind of the last wave is the property graph model.
So for all intents and purposes, for listeners, when they hear that someone is offering a graph database, most likely it'll be a property graph.
Yeah, so it'll either be a property graph nowadays, and the other one that is popular, maybe not as popular, although I don't want to comment on it, is RDF, which kind of was the previous wave, and it's gaining popularity because it's more flexible than property graphs, at least in my opinion, and it's what people associate with knowledge graphs, actually. So when it was a form of modeling it's very simple. It's essentially you model your records as a set of subject predicate objects, and that's the entire model. It's very simple and it's very flexible, and it's really meant to model very complex heterogeneous domains. So something like, a popular knowledge graph is DBpedia or Wikidata. These are very complex domains because they model encyclopedic human knowledge, which is impossible to put into tables, or for that matter, I think, really structured as a set of node records and relationship records. So RDF is more flexible in that sense. So you can think of models as maybe very structured as on this side, SQL, like relational model, where there's explicit set of columns, data types, and tables. On the other side is maybe RDF, and somewhere in between, maybe closer in my mind to the relational model, is the property graph model that still gives a graph-based model. So it's more object-oriented, it's not as structured as relational model, but also not as flexible as RDF. So that's one way to look at it.
So as far as property graphs, so I'm friends with Emil Ephraim, the founder and CEO of Neo4j, as well as a bunch of people at Neo4j, and I guess when that category first emerged many years ago, I felt, well, it's interesting, but I don't know if it's going to be a standalone category, because at some point you can do all this kind of analytic kind of calculations on other systems, right? So like, I don't know, you can use, you might even be able to use Spark to do scale out, to do some of the analytic kinds of computations. And while you might be able to do that, that's great. But then at some point, the Neo4j people started pointing out to me that, well, actually, that's OLAP, but a lot of our use cases are actually on the OLTP side.
Yeah, it's
So,
interesting.
yeah, it's quite interesting. So can you talk a little bit about use cases for property graph, or what's your impression of this, of its utility in the OLAP OLTP dichotomy there?
Yeah, so one way. So first of all, this is actually an interesting sort of property of this market, at least Neo4j as a system. So I don't know if it applies to other graph database management systems. So I actually heard it from your podcast with Emil Eifram, that their core business is an OLTP, but they're growing.
And then the emerging, an emerging source of revenue is graph data science. But let's set that aside.
Yeah.
So OLTP, I think, surprises a lot of people.
I think so too, and graph databases historically too, in any of the waves that you look at, they were never meant to be OLTP based, to support OLTP based workloads. They were always these, if you want a third class of kind of workloads, if you want to kind of, again, this is a simplification because real world analytics and real world workloads are very varied, but you can think of as OLTP, OLAP. Right, so think of the OLAP as, you get these cubes, you get these maybe dashboard applications that require
analytics, basically.
Summarize lots of records, and then some kind of graph workload, a third workload dimension. You can think of those, and what would define them? So one way to define them is that these are workloads that require some kind of recursive computations. So maybe you need to find essentially links between one account, let me take a financial network account, one account and another account, but it might be direct or it might be indirect. So some kind of recursive query, right? Or they might require essentially finding connections between your entities, but maybe through some arbitrary join paths that you may not know a priori. So this type of querying is not done in any SQL system. So you might say, like, how is this account connected to this other account? And there might be multiple relationships through which accounts might be connected to each other. And you can't really ask this very easily in SQL. So those types of arbitrary, flexible join paths are, searching for join paths is essentially a type of workload that some applications require. These are classic applications, are fraud, recommendations, risk analysis, and they have always been kind of one of several of the motivating examples. To go back again in history, I'd like to give maybe listeners a bit of a historical perspective. In 1960s, 70s, when the first graph-based systems were being built, some of them are still around, like IMS is a hierarchical database. That's a graph-based model. IBM still sells it. And it was really meant to support like some large manufacturing projects like Apollo spacecraft project, and people needed to calculate if they wanted to sort of build some component of the spacecraft, what is the raw materials that they need. And that's a recursive query because, like, a door consists of many pieces. Internally, each component consists of many pieces. And to kind of manage and query that data, they need the system, and IMS was good at that. And maybe another kind of property of these third class of workloads is if you're looking for very complex patterns, so maybe like a clique of users who all called each other on a phone network, which is again required by this, fraud or some kind of risk analysis type of applications. Again, those are patterns, and patterns people think a lot more easily as in an object-oriented manner than as a set of tables. So it's more natural to model and express those in graph-based systems, database management systems.
As a friend of mine said, in the end, given enough money, everyone will build the same thing, right? So you can express all of these queries in a relational database, but they would be so awkward, so
That's
slow,
right. Yeah,
so slow.
that's right.
But
So
a listener might say, "Oh yeah, but that's possible." Sure, everything is possible in any system, right?
I think, there is probably some threshold for users. So maybe the core principle that's, I mean, I don't want to distract your questions, but maybe a core principle that I like telling people in databases are like cars. They serve very similar purposes. They give very similar sets of features. So all need to be ACID compliant, because, when you insert records, you don't want half of them to go in and half of them to not go in. You want some guarantees. Okay, transactions solve that. All of them have high-level query languages, because you don't want to write the exact computation that will happen. You just want to express what it is. So they all really provide, similar set of features like high-level data models and whatnot. And it's like cars. So, there's a threshold to which certain cars can do certain things. Like with your Tesla, you'll do certain things. But with your pickup, you'll do some other things, or with your Jeep, you'll go to other terrains. So there's probably the core principle is that you keep using the database that you're familiar with, right? But at some point, the kind of work that you'll have to put into your comfortable database becomes too much that you'll want to switch. But as long as you can keep using your database, it doesn't give you performance features. It doesn't give you, so it gives you the performance and scalability features that you need. And it's the quickest way to do your applications. You'll probably resort to it. But, and at some point, some applications do really require people to switch databases.
And by the way, for our listeners, graph databases in particular, while I was skeptical many years ago, it is now somewhat of a category, right? So just look at the amount of revenue that Neo4j, for example, is throwing in, and we can't say that yet for this other category called vector databases, which we will set aside for now because that's another can of worms. So all right, so Kùzu. So what motivated the development of Kùzu, and what differentiates it from existing graph database management systems?
Yeah, so the sort of a brief story of Kùzu is that when I was entering this area, that was about 2017 or so, that's when I took my position at University of Waterloo. Prior to that, I was still working on graphs, but doing distributed graph analytic systems. So this was the era of MapReduce and Pregel and systems like that, if you're familiar with Pregel and distributed graph systems. So there's really no market for that. But so I was looking into graph technology space, and I did a user survey. I do recommend people to take a look at that. I think it's still relevant today, although it's been published 5 years ago, about kind of what are people doing with graph? What are the common classes of graph technology? What are their problems? And something that was very visible in that survey was that the graph database was the biggest market, and people had major scalability and performance problems. So that's what we studied for many years in a prior system to Kùzu called GraphFlow. Essentially, this was the research question. If we were to re-architect a new graph database management system, modern graph database management system, what would be the principles on which we'd architect that? So we did publish a lot on that prototype, and as we were kind of approaching 2020, 2021, we decided to rewrite it. And at that point, DuckDB was becoming very popular. And I was really liking the way DuckDB was kind of, in some way, kind of disrupting the analytics market. So they had a new way of kind of showing people that a lot of the analytics can actually be done on a laptop with very embeddable OLAP system. And we wanted to take DuckDB's usability features with the research we've done on GraphFlow into a new system that will build like DuckDB from academia, so as a usable system, and over time, hopefully grow a user community. So that's kind of the story of Kùzu. So it takes DuckDB's usability and performance features of kind of GraphFlow. And those include, I mean, we can get into this however much you like, but several novel join techniques, several storage techniques that are all getting into the system as we develop it right now in the open source.
So let's revisit DuckDB in a second, and I'll hold your feet to the fire when it comes to your claim about DuckDB. But first of all, one of the things that a listener might say, Semih, is, when I encounter these graph people, right? So the people who work in graphs, one of the things they like talking about is how many nodes and edges they have, right? So my graph is big. I have 2 billion nodes and 3 trillion edges and things like that. So it's counterintuitive to have to do something in graphs that actually emphasizes embeddable and small. Or maybe that's just a stereotype, just like in big data, right? So in analytics, people claim like, oh yeah, I have a query that I have a billion row table joining another table, and so, but then it turns out the vast majority of their queries can be run on a smaller system, right? So maybe it's the same thing with graphs. People just like to brag about the size of their graphs, but most of the time they actually don't need a big system.
Yeah, I mean, that's kind of the position of Kùzu. The reason we are building Kùzu is a single node system. Right. So it is like DuckDB in that sense. So in that sense, you might, but it is meant to change this perspective that in a single laptop, you can only manage small graphs. That's not true. Graphs especially has this kind of some thing attached to them that people think that graphs are hard to manage and you can't do certain workloads. That's also another thing we want to break. So I think if you implement your system, if you implement the storage and the query processor correctly with several novel techniques that the field knows, but like a technique is factorization, for example, which is a way to compress kind of join results when the joins are many to many, which is the natural thing in graphs. Like one user might be connected to 100 users, and those, when you do search patterns, those joins grow very quickly. But there are techniques to mitigate these that the field has known, but they were not implemented, but are being implemented. So we want to show people that you can actually manage large-scale graphs on your laptop. Plus, I mean, this is kind of a fact of life that every kind of, as you'd expect in many phenomena in life, things are going to be distributed in a, skewed manner. So like there'll be kind of exponentially fewer people, or at least polynomially fewer people with larger and larger scales of graphs. So a lot of the sort of use cases will always fall into kind of by the nature of life that, into smaller data sets. So a lot of the data that people have don't require, I think, distributed solutions and can be done very efficiently in a single node.
And it's also probably just a biased sample on my part, because most of the people I talk to in Silicon Valley probably, they feel obligated to talk about how challenging and how big the problem is. But as you point out, in day-to-day life, probably that's the exception rather than the rule, right? So
I think so too. So I think, we'll see how much we scale. Obviously, we want to, that's our kind of bet, is that we want to show people that for most of your workloads, so like you should be able to manage, a terabyte, several terabytes of data on a laptop that has enough SSD. So that's kind of the bet. So that's kind of probably the upper limits, but a lot of people don't even have that size. And, if you kind of implement your storage correctly and query processor correctly, you can manage and do kind of graph-based querying, complex graph-based querying on a single node. And it's also good to remember that people make these mistakes a lot, that they overestimate what they need and kind of budget too much. We saw this a lot in the MapReduce kind of Spark era, where because certain hypes kind of become very, certain things become very popular, there are hypes and people think that they need to use those solutions. But then in reality, if once you show people and give them the right software, they can see that they could do it in smaller hardware in a cheaper way. There's a very nice, just as an anecdote, there's a very nice paper that was very popular by Frank McSherry, who is at Materialize now, but he was one of the people to observe that a lot of people were kind of building these distributed systems for small problems, and it wasn't really justified. So it's a very popular paper called Cost, Scalability, but what at cost, or something. That was the title of the paper. That is essentially making this point that people are kind of exaggerating how much resources that they need.
So in the embeddable database market, obviously, so you have DuckDB on the OLAP side, but the granddaddy of this space is SQLite, which is on the OLTP side. But it's interesting because the SQLite folks, and correct me if I'm wrong, Sammy, I think they just released a paper which basically, in essence, and this is my kind of reading of it, says, yeah, so we can add a lot of the things that DuckDB can do, but if we do that, we'll make our system much more complicated, and it moves us away from our mission of doing a lightweight embeddable system for this particular workload, which happens to be transaction oriented, right?
Yeah, I haven't read the paper. I know it. I actually know that apparently in the conference when this was presented, there was some arguments or like some debate. I mean, friendly debate, I'd assume, but between DuckDB, some DuckDB person and the presenter and whatnot. So people told me about this. I don't know what's sort of, I think, the position makes sense to me. For any system, if you implemented enough features to it, you could kind of make it better in some kind of workloads. But the question is, how much sophistication do you want?
But it also defeats the fact that your system is so lightweight and easy to use, right?
That's right. Yeah. I mean, it's inevitable too. So, I mean, I think there are popular topics like let's build a system that's both good at OLTP and OLAP, but they're fundamentally, you got to pick whether or not you'll be read optimized or write optimized. It's kind of
it never works. The H tab.
Yeah, I don't know that people claim that they do, but to me, it's intellectually at least a bit dissatisfying because we know, for example, at the storage layer, you have to be
column or row. Right?
Column or row, roughly. Those are the two. There are like in between hybrid things, but you got to optimize for one thing. Like it's very difficult to optimize for multiple things at the same time because the code lines start looking very different. So you kind of implement different code lines for different things, and so to me it makes sense that if you want to take SQLite and then implement a lot of DuckDB's features, it's probably going to complicate your system.
So Kùzu, the kind of the unofficial tagline, DuckDB for graphs. So
that's one way I summarize it. I actually have a different way of describing
it. Hold on. So is there a SQLite for graphs?
No, there isn't any. Okay. Yeah, that's not a very interesting area, or that's not a very promising area because graphs are not meant to be in general. Again, historically speaking too, I know there's this Neo4j example that apparently makes more money through OLTP, but historically they've always been for analytics. And if you're doing it for analytics, you want to make it more read optimized.
I don't know for a fact the breakdown of Neo's revenues, but I would say that OLTP is non-trivial, data science non-trivial, analytics non-trivial.
Yeah, so if in your podcast, if I remember correctly, I think he was saying there's more money being made right now OLTP, but the growing part is data science. Yeah.
All right. So now the DuckDB tagline. Let's go through the DuckDB key features and see how it maps to Kùzu. So first, fast in analytical queries. Kùzu, yes, no?
Yes.
And
okay, analytical though, sure, yes, yeah. It's read optimized. It's read optimized. It's not write optimized. Yeah.
And then for DuckDB, it's SQL support. For you, it's Cipher support.
It's Cipher. That's right.
And so is Cipher now become kind of like the SQL for graphs? Or the Tiger Graph people trying to push something else, right?
Tiger Graph is its own language. The Cipher certainly has the most, I think, users right now, and Neo4j is doing a lot of efforts to popularize both Neo4j and Cipher.
Cipher, to be clear, Cipher to be some kind of open standard, right?
Yeah, there is an effort to have a new graph query language that is gonna look like Cipher in some ways, with additional features and whatnot, and probably eventually a lot of systems will implement it. We'll see, but it hasn't come up yet. But Cipher is, I think, people really like Cipher. So that wasn't a bad choice. That was a good choice. People really, really like Cipher as a language. But to me, query languages are all SQL-like are all like SQL, by the way. So they're all, any high-level query language looks very similar to SQL, and so does Cipher with some nice graph-specific syntax.
And I attended one of the first, if not the first, meetup where they talked about Cipher, and I actually thought, oh, this is interesting, but I wonder if we can just use SQL somehow. But then SQL is inherently set theory related, right? So you needed something else, right?
Yeah, so you need certain syntax for several recursive computations for sure. Like if you want to do like, is this node record connected to this other node record through direct or indirect things, like Cipher has this clean star syntax, just like in regexes. You spend a lot of time trying to write such recursive queries in SQL. Or if you wanted to find shortest paths, which is a common sort of recursive computation, very, very difficult to write in SQL. So SQL, one of the sort of major shortcomings is recursive computations, because it was something that they taught 20 years after SQL was standardized, and it's a hack basically. It's not a very nice feature of SQL. So there's sort of several features of Cipher like that makes it very easy to express certain computations.
And for a system like Kùzu to support Cipher, the reason you do that, as I was alluding to earlier, is Cipher is some sort of open standard that it's not like it's completely controlled by Neo for J.
There is Open Cipher, which they have kind of put out, so we can actually take that and use it. So they are kind of encouraging because they'd like their language to.
So it's more, many people in the graph space use Cipher.
Yeah, MemGraph is another system that implements Cipher, and I've seen other kind of systems, at least certainly from academia, that try to take Cipher and implement parts of it. Yeah, so there's an open standard around Cipher.
All right, so going back to DuckDB, my mapping to DuckDB. All right, so integration with other programming languages. So DuckDB has APIs for obviously Python, Java, C, R, Julia, Swift. So what's the status of
we have currently Java, Rust, C, and Node.js. And
no Python?
Python, obviously. Python is the main one. Python and C++ is the language we're using to write. So the core APIs in C++, and we got bindings, Python, Rust, Java, C, and Rust.
So you're not a hipster database because you're not written in Rust or Go.
We are not. I get this question all the time, and it's because we don't know Rust. And the people like me and my students, when we started writing it, none of us knew Rust, and I think we were too lazy to try to learn it. And I was intimidated by it, so I didn't want to learn it. So I said, let's do C++.
All right. So what's the license?
MIT license, just like DuckDB.
Awesome. And simplicity and portability. What can you say there? So how easy is it for someone to get up and running? And
again, we try to follow DuckDB in many of these cases. So in Python,
Semih, I have a friend who has this test, right? So if I hold my breath and then start installing, running, can I get something up?
Yes, you can. So if you did pip install Kuzu, and then you can start your Python script and start creating your database. It is easy, obviously, but DuckDB has several other features that, for example, can scan from raw formats, can scan directly from Postgres. We don't yet have those, but we have those are in our roadmap. We're a lot newer system, but we like those features of DuckDB a lot. So those usability features are important to us, and we try to follow DuckDB in those cases.
Yeah. And so the other advantage of DuckDB is people just have a lot of tabular data, CSV files, Excel, and stuff. So I think one of the challenges with graph, Semih, is that people just don't ordinarily think in terms of graphs. They don't have graph data lying around, right? So,
Yeah.
so your system assumes that someone already is comfortable with graphs. They have graph data. So, in other words, the people that you're targeting to try out Kùzu already have the graph data lying around.
So we try to not make that assumption. We try to assume that the data is sitting in some tabular format as it always does. So, tables or graphs these are modeling choices of the records people keep. And, if you got some records that you've collected and you may have put it, often you'll first go and put it into some relational system, or maybe the relational system is your primary kind of system of record. But we do want to have features that allow you to essentially model exactly the same records, also in the form of a graph, because some of your applications, again, may need these beyond SQL, beyond relational kind of capabilities, like recursive queries, arbitrary join paths, and many-to-many sort of patterns, like find me the cliques of users in my records and things like that. So we want to make that easy, but you are right that originally often the data lives in a tabular format. People keep their records in some tabular format originally. Yeah.
And
So,
what is the status of tools generally, set aside Kùzu? What is the status of tooling for people who, let's say, have tables, and tables have relationships, maybe even a schema? And what is the status of tools that takes that kind of structure and turns it into a graph?
I am not sure if there are kind of standard tools just for this. The different systems implement different things.
Yeah. My friend has a particular tool that he has, but I'm not sure if generally a lot of people are aware that these tools actually are beginning to emerge, right?
Yeah, so even I may not be actually fully aware of exact the tool sets people have for kind of extracting data from a relational source into graph databases. But different systems have their own tooling that they're building. So I can't say that it's very advanced or as kind of popular. It's kind of a nature of that the space is also smaller, so there's fewer toolings that are being implemented. But every system, obviously, like Tiger, Neo4j, I'm sure memgraph does it to try to build some features so to make it easy for you to move data from a relational source into them. We haven't done much on that yet, but obviously we'll have to do it at some point as we continue.
All right, so going down the road of the DuckDB mapping here, so performance. So yeah. DuckDB is fast, right?
That's
so
right.
Particularly for analytical workload. So obviously you're going to tell me you're fast.
Yeah, we are.
What's the proof?
Yeah, so
I guess there must be benchmarks that you guys did, right? So
there is a publication on Kùzu where we do some benchmarks again. So this is an area where it's difficult to have a certificate saying we are like this. Everybody.
No, but this is in many ways for you guys. This is, besides the simplicity and the fact that you can run it on a laptop. If you're not fast, it's over, right?
That's right. So this is actually our expertise. Like all years of research we did was on performance and scalability. So we are the first system to implement several techniques from the database field, like factorization, like worst case optimal joins, like this. Kùzu has a very specific hash join-based join algorithm that is different than what most graph databases use, which is index nested loop join algorithms. And I'm getting a bit technical, I realize this, but this is actually what we are trying to perfect. We want people to see, like without perfecting this, actually we can't validate our bet that you can manage large graphs, because managing large graphs require these advanced techniques that we did a lot of years of research on in the previous system to essentially be very efficient on these many-to-many joins, recursive joins, and things like that. So like my expertise as a researcher is in this. Like I know how to query and store graphs in a scalable and performant way. So a lot of those techniques are getting into Kùzu. So this is actually a part where I'm most confident about. Like this is the part because we know the most. So so I don't doubt that over time people will see that our query processor principles and our storage principles are the sound ones, are the state-of-the-art ones, at least currently.
But for the typical Kùzu user, maybe a graph data science person, they're interacting with the system through Cipher, and then they're reaping the benefits of all of these performance optimizations.
That's right. So we hope to show that you got complex recursive query, you're trying to find complex patterns across a large scale graph, and we'll be able to do that better than any other system with the help of these techniques that we are implementing. So one thing I can point people to, so I would have to get very technical, but is first the Kùzu paper. It was published in Cider, and I also wrote several blog posts about some of our core features on our website. So there's factorization, worst case optimal joins, initial blog post about our vision that describes the set of sort of features we want to implement. So all that it gets into very technical sort of features of the system, but just again, this is the part where we are the most experts in, so we are more confident about this than say getting the usability features right, for which we haven't done before. So it's kind of an experience for us, but for those cases we are trying to look at other systems and what others have done.
So for the listeners who are starting to get intrigued by Kùzu, so is Semih, is the kind of the scenario you have in mind a user with a laptop working on using Kùzu by himself or herself, or is it also, I mean, just as in the case of DuckDB, you can imagine people installing Kùzu in a beefy server and then multiple people using that system, or is it does it actually support concurrent users?
So we support concurrent users. So embedded systems have this problem, and DuckDB also has this, that if you want it to be the system which you're kind of putting behind an online application. So maybe there's
or not even an online application. Let's imagine a small team of data scientists, 3 to 5, right? So
yeah. So like as any database management system, this is not specific to Kùzu or even related to it being embedded. Like you need to support concurrent reads, concurrent writes. Again, these are kind of standard features that come with it. So we can right now support multiple people querying the same database. So embeddability gives several disadvantages, like maybe a slight disadvantage, that if there are concurrent writes, they need to come from the same process. If not, you need to wrap it around a simple API server so that you kind of manage it. But DuckDB does the same thing. These are kind of simple solutions. There are standard solutions to this. Yeah, so like we do imagine a case, actually, to the listeners too, we are a seeded company, and eventually we will have to essentially kind of have users that are using Kùzu on large data sets, which means now we are going beyond this laptop case and people want a single machine, but still cheaper than buying distributed solutions and whatnot, managing large scale data on multi-core processes. And in that case, we are assuming multiple people are doing analytics on the same data. So we'll have to kind of support that case.
So how old is Kùzu?
Kùzu is less than a year old in the open source, and about 2.5 years in maybe getting close to 3, maybe 3 years old, old in terms of when we started implementing it. It was very slow with me and one of my master's students for a while. Actually, it was my master's student for a while. I had recently become a dad, so I was kind of out. So he was kind of single-handedly for a year implementing it. Then the team grew a little bit academically, and we open sourced in November 2022, so less than a year from now. And we've been in the open source since then, but real development really started around early this year. So for the last sort of 9 months or so, there's a real team, and around March we became a company. So now there's actually full-time employees. Before then it was always kind of a mix of students and studying and implementing on the side. Now there's a serious sort of full-time engineering team behind Kùzu.
So since it's been released to open source, so what are some of your favorite use cases?
It's a good question. So we are still early. So the community on our Slack, there is about 120 people. It's not a very large community. A lot of people don't know about Kùzu. Part of the reason is that we still need a bunch of more features to develop. But there has been people in some Canadian banks using it for some fund analysis. There have been people using it for AWS permission analysis. Some people using it for a variety of other reasons, some social media analysis. So there is a kind of a bunch of people who are using it. Maybe a couple are really production and others are really, hobbyists, and they're doing it for maybe ad hoc projects in their enterprises and whatnot. Yeah, so we're still in the early...
It's the typical use case. We have a graph and let's ask some questions.
Yeah, let's ask some recursive questions is the most common that we are seeing, which has, again, it's not surprising, but it's always what has motivated graph-based analytics in every kind of in every wave of graph technology graph database technology that has emerged over history. So a lot of sort of recursive querying, or sometimes finding some patterns, like, are these three people connected in a social media app and things like that, which are kind of cases that we knew.
Because probably the reason I asked Emmy is probably listeners are like me in the sense that, we hear about graph neural networks. You look at the number of publications of graph neural networks, they're exploding. But then, I don't know if you caught my conversation with Emil of Neo4j. I asked him, he said, yeah, it's interesting. He said, it's really growing in academia, but he said in industry, it doesn't seem to get past the prototype stage, except for a very few really kind of sophisticated tech companies. So there's a disconnect between kind of graph machine learning in academia and graph machine learning in industry. I don't know. What do you think?
I kind of agree with this. That one of the ideas when Kùzu got launched, graph machine learning was even more popular than I think it's now. I think it's a little going down. And so we said, okay, let's, again, for usability features, we are trying to follow DuckDB. And one thing that DuckDB did very nicely is for the tabular data science, they integrated with those Python libraries. Right. So we said, what is out there in terms of graph libraries? And NetworkX is one, for example, in the Python space. And in terms of the most sort of hot space in sort of advanced graph analytics, it was graph machine learning. So PyTorch Geometric is the, right. And DGL are the main libraries. So one of the first features we did was integrate with PyG, and you got this nice feature where Kùzu can be a remote backend for PyG. So if you got large graphs that don't fit into PyG's in-memory store, and you need to kind of scan your features, node features, and do your traversals off disk, you can store your graph and sort of embeddings features in Kùzu and do that. So we did that, and there's been a little interest in that, but it was kind of for us a little bit of invalidation. We're still waiting to see if that community really exists in the industry. One thing that's a little intellectually dissatisfying about graph machine learning, I think, is that if you do deep net graph networks, you kind of are assuming that you're going to learn something very useful from your fourth degree friends or fourth degree neighbors. But that's a little intellectually dissatisfying, because 4th degree, 5th degree means everyone, right? So graphs connect it's very well known. Graphs really in real life.
Kevin Bacon
idea, right? So so what is the specific advantage of graph-based models over maybe some other more standard machine learning models? There's always been a question. I kind of am getting similar signals. I don't want to say I know this very well, but there's maybe 2 or 3 people that have contacted us so far about using Kùzu from industry. I mean, using Kùzu as a PyG remote backend, or using some of Kùzu's PyG features. Not a lot. So we were very excited about it, and now we're waiting a little bit to see kind of if industry will catch up with that or not. We'll see.
Of course, with any database, the first thing users want to do is get data inside the database.
That's right.
So what are your most popular connectors or integrations at the moment?
This is one part where we need to do more work, but you can essentially right now get data from raw files like CSV, Parquet, NumPy, Arrow. If you store data on disk in Arrow files. So those are the 4 file formats that we support. One thing we are working on right now is to directly get it from in-memory Python objects. So if you've got a pipeline that has created a data frame, a pandas data frame, you'll be able to directly read from that and ingest into the system. So in our last release, we try to release every month now. It was sort of 2 months since the last month, but since last 2 months, we've been releasing monthly. Last month, we had our first direct scan feature. So you can start scanning directly from CSV files. We want to have similar things where you can start directly scanning from other like Parquet files and other files. By that, what I'm trying to say is that that's a little different than kind of ingesting into this. You can bypass ingesting and do some querying on CSV files. So that's a feature that we are working on, which is again ways of making it easy to do your analytics. So if you can bypass the ingestion step because you got this thing that you want to do only once, so that's a performance advantage, simplicity advantage. So we are giving several features like this, but we've got more to do in that space.
So I have a half-baked idea for you.
Okay.
Which is, as you know, one of the hottest things right now are foundation models, large language models. And kind of the hello world example there is retrieval augmented generation. Right. So right now, most people, when they do RAG, it's vector search, vector database, right? So which I don't think is a viable standalone system. But again, let's set that aside for the future. So, but then on the other hand, teams like Neo4j, they're starting to kind of say that, hey, you know, if you have a knowledge graph, that could also be a nice way to build a RAG, retrieval augmented generation system. So then you could be like the easiest way to have a knowledge graph as part of a RAG, Kùzu, because Kùzu is lightweight and so on and so forth. But here's the reason why it's half-baked, Semih, which is basically most people don't have a knowledge graph, right? So most people have PDFs, and PDFs they can index and store in a vector search system. Now, if we had like some magical tools which say, here's a S3 bucket with 1,000 PDFs, and somehow this magical tool will create a knowledge graph, which I then stick into Kùzu, and then now I can build a RAG. But see, the thing is, most people don't have knowledge graphs. So we need to fix that part, right?
Yeah. So, but there are actually predating sort of LLMs. There has been successful startups like Snorkel. If I forget, maybe I'm confusing them, but there's a couple sort of startup from Stanford, Chris Ray's group. Based on that, like how do you take PDFs and convert to, or like
I don't know how successful they are because no one seems to know.
So okay, this is a part I shouldn't comment much, but there has been activity at least. Right. Startup and like, you know.
No, but my point is that most teams right now, they don't think in terms of taking that step of going to knowledge graph first, right? So they just go, here's raw PDFs, that's it. We index, we do information extraction, we index, stick it in a system. But if you had a tool that can somehow create a knowledge graph out of that, and knowledge graph, once you have it, let's say you have a decent knowledge graph in Kùzu and you start doing RAG, not only do you get the answer, your answer might even be explainable. Because right?
Yeah, because you've got explicit relationships between kind of your concepts or whatever your class structure is, and you can kind of do sort of RAG by getting all these subgraphs and contexts. If people talk about these, but I do agree. Like one problem is that aside from major companies like Google has knowledge graphs and Amazon has knowledge graphs, like big company Apple has major knowledge graphs. Like Apple has a team You know, we were talking about this before. EHOP's team actually manages knowledge graph. They publish in about their knowledge graph that powers Siri and applications. So major companies do have knowledge graphs. So that could become more popular. Like the need to.
But those are internal, right? So I'm thinking
those
about.
are internal, but there's also companies like chemical companies, pharmaceutical companies that manage Siemens, large knowledge graphs. A lot of large enterprises manage large knowledge graphs, and they need to build their own graph stack. And if they need a system like Kuzu or a graph database that's specifically tailored to build LLM applications, so we might be in a position to kind of enter that area. Although, you know, this is an area we're monitoring. You know, I don't want to too much. It's an area that I haven't done a lot of sort of work on. So we'll see. You know, this is exciting, and hopefully,
in principle, Sammy, let's say I already have a knowledge graph, and I stick it inside Kuzu. So I guess what Neo does is, okay, so I have a knowledge graph. I can actually also do embeddings based on that knowledge graph, and then make those embeddings searchable somehow, I guess.
Yeah.
Right?
So you can store embeddings in Kuzu too. So I think there'll be a couple features that's needed. You might even need to mix these with even text search, like, you know, because you get a
hybrid
question, natural language question. You need to figure out which entities in your knowledge graph map to it. So that might be kind of another index. It's not a vector index even. It might be like, okay, you know, Ben Lorica, which of these entities, nodes in my knowledge graph map to it? And that might just be done. You don't need to maybe go and map Ben Lorica to a vector and search. Like, you might just do it more quickly with a text search index. So it might be kind of a mix of a few indices that need to come together with some graph-based querying to extract certain facts that you give to your LLM to answer some questions. So it's again, like, it's all speculative, obviously, but exact feature set that would be needed is a little unclear. But the first thing is for the area to actually mature up a little bit, I think, so that people have better ideas about what works, what doesn't work, what is really needed.
In terms of integrations, do you do integrations with graph visualization tools?
So no, this is in our pipeline. So we got our own visualization that's actually coming up in a week. So just like a lot of graph databases have their own front ends where you can visualize your graphs. So that's coming.
Also open source?
Oh, everything's going to be open source. So that's going to come up in a week or so. Like, by the time this is published, it should be open sourced. And we do integrate with NetworkX. NetworkX has its own visualization. And we got a few things like PyVis, Cytoscape, some of these open source popular graph visualization libraries that we want to integrate with. We don't want to kind of do something very advanced our own, because there's already existing kind of libraries. So we want to essentially facilitate people.
That's why I was asking.
Building these things. So there's a couple sort of Python libraries in our pipeline that we're going to integrate over time, but it's certainly, you can find these in our GitHub issues where we say we want to integrate with these things, and there is some GraphViz libraries there.
Do you know my friend Leo, Graphistry?
I listened to the podcast and read your blog post with him.
Yeah. So he has a visualization tool, GPU though, GPU acceleration. So I'm not sure that would. I'm not sure if you would be able to talk to his tool.
Maybe if it's, I checked it though. I can take this offline, but
What about so what's your guys' thinking around streaming in real time? Is that not inherently part of analytics, or you know, so do you assume that, you know, I periodically reload the database? So what's your position there?
We assume, so we don't have features, or we don't even plan to have features where you'll be able to stream things into Kùzu. For now, real-time dashboards though, Sammy. Real-time. So, you know, for those dashboards, you will need a system like maybe Materialize, right? Instead of a graph-based system. So one thing, like the other reason is that just technically, if you want to be a real-time system, a database engine, you need to have sort of be an expert and very good at incremental view maintenance techniques. And so we don't even have many graph databases actually any of them that I know don't have even a notion of views and incrementally maintaining it. So that's one reason. I think this gets very useful and interesting if you can ask queries and now they're continuous, something like what Materialize does, right? So you can kind of stick a query to the system and says, I want to continually kind of update the answer of this query as data will come in. And they got essentially these advanced incremental view maintenance sort of techniques that they've integrated. So that's an area where we haven't done work, and it's even a little unclear in a graph database what your view should be. So that's kind of like an open question, I think, in the field.
So in closing, Semih, so Kùzu obviously started out in your group at University of Waterloo. Now you have a startup. So give us a sense of the community. Are the contributors mostly around Waterloo, or are you starting to get contributions from outside your core group?
Yeah, almost all of it is Waterloo based. People from my group who are at the company now. We are got about 9 people who are full-time engineering. 4 of them are interns, 5 of them are full-time, and I sometimes contribute, although less and less so. And then we get a few sort of PRs that are opened from time to time. People who needed something and they'll do it. We got one contributor who did a .NET, actually .NET. There is a .NET but external kind of API to Kùzu, which we didn't build. So a couple of people, when they need something, they do it. And then one of them, for example, was nice to open source it, so we can link to it. So stuff like that. But most of we have a tight control so far of what goes in, and so the other contributions are small. Hopefully, as we grow, we're a little young, actually very young. So over time, hopefully, we'll get more and more contributions.
Yeah, I think honestly, your system looks cool, but you might need to also invest in developer relations, obviously, but also and I guess the other companies like Neo and TigerGraph are doing this too, but just making graphs more easy for people generally. Set aside Kùzu, but make graphs like simpler.
Yeah. So one contribution I hope Kùzu makes is in the kind of spirit of making graphs easy, is to show people that you don't have to resort to systems like Spark, systems, these distributed solutions, and often they are not graph-based, to manage large-scale graphs, because people like Cipher. People want to ask sort of these queries, either recursive or complex pattern queries, and do analytics based on those queries. But then, because most of the systems, graph databases don't scale, they kind of give up and they'll say, you know what, I'll either do something my own, or will essentially go to Spark or something like that, so where they can scale more freely. We want to show people that you don't have to do that. You'll get a lot more productivity. So that's another way of making graphs easy, and that's where we are strongest. I think that's where we hope to make a contribution in the field. Yeah,
and then hopefully some people are listening to this episode work on that aspect of just taking data and converting it in a format that these graph systems can take advantage of, as we alluded to, right? So, I guess there's already tools that take tables and turn them into graphs, but now we need like tools that take kind of the raw material for retrieval, augmented generation, whatever they are, web pages, PDF files, Microsoft Word documents, and then turn them into knowledge graphs somehow.
Yeah, that would be very useful. If there was a technique that just took sort of PDF files, text, and said, here's a knowledge graph that represents this, that would be a very, very useful technique to popularize sort of knowledge graphs, and that would inevitably popularize graph databases as well to manage those knowledge graphs.
And with that, thank you, Semih. And of course, I'll link to Kùzu and the relevant blog posts and to the company website as well.
All right. Thank you so much, man. Thanks for having me.
All right.